Okay, the question is, box A contains 5 red paper clips and 1 white paper clip. Box B contains 7 red paper clips and 2 white paper clips. One paper clip is taken at random from box A and transferred to box B. One paper clip is then taken at random from box B. The situation I have drawn here in this paper. So at first we have to draw one paper clip from box A and we have to transfer it to the box B in the first case. And for this, the probabilities of the red paper clip and the white paper clips are here. So total are the 6, and the red paper clips are 5, so we put 5/6. For white paper clips, the probability is 1/6. When we transfer one of the paper clip from box A to box B, the probability of the red paper clip and the white paper clip can be altered. Let's suppose the first paper clip we took from box A and transferred to box B is red. Then the total would be 10. It means, let's suppose this is red paper clip, that it will become 7 plus 1, it will be 8 now. So 8 over the total will be 10. So 8 over 10 will be the probability of drawing a red paper clip from box B. In the same way, if we calculate the probability of taking white paper clip from box B, so there is no any change in actually the white paper clip, because in case we draw red paper clip from box A and transfer to box B, so only the change is in red paper clip. So this 2 remains same, but the total becomes 10, 7 plus 1, 8, and 2, 10. For the white paper clip from box B, the probability is 2/10. This is the case when we draw a paper clip from box A which is red. Let us suppose, in the second case, let us suppose the paper clip drawn from the box A is white. Then there will be this change in the white paper clips. The initial was 2 white paper clips, but if one is drawn, it will become 3. 2 plus 1, 3. In the previous case, it was 7 plus 1 red, because the case was red drawn from B, drawn from A, and add to the box B. But in this case, we are taking white paper clip from box A and add that white paper clip to box B. Altogether these are 3, but the total are 10, 7 plus 3. Oh, in the denominator we have to write 10 total. For red, same, but for white it becomes 3. So these are all the probabilities of having the red and white from box A, these two, and red and white from box B. But there are 2 cases. The probability of drawing the paper clip from box B depends upon the drawing of paper clips from box A. If this is red, these 2 are the cases. If this is white, these 2 are the cases. The whole situation I have drawn in the form of the tree diagram. There are 2 draws. In the first draw, there can be red paper clip or a white paper clip. The probability of red paper clip is 5/6 written here, and for white this is 1/6 written here in the first case. But in the second case, when we draw the paper clip from B, from B we have to draw the paper clip from B. So the probability of drawing red paper clip, already drawn red paper clip from A, is 8 over 10. This is the case. And for white, this is the case. When the paperclip from A was white, so the two cases arises here. So two cases arise here for 7 over 10 for this red and 3 over 10 for white from this. All right, this is the whole situation which was in the main question, question number 7 of November 2007. Now we have to give the solution of the parts. There are 4 parts: first, second, third and fourth. So I'm taking first part. Okay, first part. So I'm reading the first part first. Find the probability of taking both a white paperclip from A. So the probability is 1/6. Then a red paperclip from box B. Then a red paperclip from box B. So first white, then red. So this can be the answer. This and this. And I forgot to tell you how these all come. So multiplication we do actually along the branch. We multiply this, you'll get this. This multiply this, you get this. This one, this, you get this. So again, I'm reading the first part. Find the probability of taking both a white paperclip from box A. From box A, this is box A, this is box B. So from box A, so the white paperclip from box A and a red paperclip from box B. So this and this multiplied, so 7/6 the answer. There is a situation when white paperclip is drawn from box A and red paperclip from box B. Second part. The probability that the paper clips taken from box B is red. They're not saying from A it is red or white. They are asking the probability of getting red from box B. So red from box B is this case and is this case. These two are the cases. Okay, for these two cases, two probabilities are there. First one is 2/3 plus across the branch we add, and along the branch we multiply. But this is across, we have to add 2/3, 7/6, 60. Right. So if we add these two, we'll get 47/60. This 47/60 we'll use in the third part. Okay, it follows. The third part is, okay, so I'm forget third part. For the third part, what is written? Given that, find the probability that the paperclip taken from box A was it. We have to find the probability of red from A. Given that the paperclip taken from box B is red, given that box B and the red, the paperclip taken from box B is red. This is given that. Wherever these words given that are given that are given, we should think about the conditional probability. When something is previously given and this given that can lead to our probability, or this given that can affect our probability of getting some R or for say some A. Okay, so this given that, whenever it is given that words are given, so we should think about the conditional probability. Conditional probability. What is conditional probability? When probability of first event is given, and the probability of second event is required, or first is required, second is given, or the other way we can. So probability of finding A given that B would be equals to the probability of A and B divided by probability of the given that. Probability is given. So we have to remember that always given that is in denominator and the probability of both together is in the numerator. So this is the formula. Okay, so we have to find actually the probability of red from A given that red from B. So this will be the probability of red from A intersection or and the probability of red from B. Red from A, red from B. Okay, divide by the probability of given. Probability of given is red from B. Alright, red from A and red from B is this case. Red from A, red from B is the probability is 2 over 3. 2 over 3. Divided by probability of red from B. Red from B. Red from B. This is red from B. This is red from B. The total probability in the second part of the question was 47 or 60. 47 over 60. So the answer is, using your calculator, 40 over 47. 40 over 47. This is the answer of the third part. Here we use the formula of conditional probability. Whenever some probability of some event is required along with some given that is given. Okay, fourth part. In fourth part, the question says random variable x denotes the number of times that a red paper clip is taken. A red paper clip is taken. So red paper clip is taken here 0 times. Red paper clip, there's no any red paper clip. Here 1 time, here 1 time, and here 2 times. So here 0 times, 1 time, and 2 times. So we can write the probability distribution table. So this can be the probability distribution table for x 0 time, 0 time, r. X is actually the probability of getting red 0 times, 1 times, 2 times. So probability of getting x is red for 0 time. The probability is direct 1 over 20. 1 time, these two are the cases, 1 time and 1 time. These two are the cases, 1 over 6 plus 7 over 60. So 1 over 6 and 7 is 60 altogether, it makes 17 over 60. And 2 times, this is the probability. So we can write it directly, this is 2 over 3. 2 over 3. This is a probability distribution. Okay. Draw up a table to show the probability distribution. Yes, this is the probability distribution table. So we can check it, we can cross check it by adding all the probabilities, and we know that summation of all the probabilities is always 1. So 1 over 20 plus 17 over 60 plus 2 over 3. The answer of all these should be 1. The total of all the probabilities is always 1. Okay, thank you for watching.